there are different types of data centers out there. There are ones that are sort of buried within infrastructures, and there are ones that are more exposed to the outside. But in general, what goes on inside of a data center, as well as inside any large network, can be a bit of a blind spot because it's very costly to deploy things like IPS devices and firewalls at every major junction in the network. But we'll talk about that in more detail. We'll talk about the major threats that are facing the data center, which would of course be malware and DDoS. You don't want a malware infection getting there and spreading like wildfire. And then of course DDoS. That's something that's been in the news a lot more, and it's been sort of a hot topic that I've heard more often than I had in the past. So I'll talk about some examples of that. The example that I have actually covers a pretty sophisticated DDoS attack that occurred last year. And then bridging the gap, the visibility gap with StealthWatch. So then we'll talk about the technology that StealthWatch uses and practical ways that you can implement it in your environment. So let's talk about the data center as a blind spot, and let's talk about some of the things that have been done already and things that might need to be done. So first and foremost, IPS, next generation firewall and AV, these types of things, they do cover a pretty good bit, and they're actually quite good at it, but they do leave gaps, and those gaps come because of the fact that they're costly to deploy. If you were to deploy an IPS device at every single major intersection of the network to get the visibility of packets actually passing through those devices and using them in a preventative capacity, that would get very expensive really, really fast. And it's very much the same argument for next generation firewall. Next generation firewalls, they typically introduce NAT into the problem, and so there's a layer of complexity that comes with that, and then there's also the fact that they suffer from some of the same vulnerabilities that IPS does. Placement of these devices has been typically at the edge, so at egress and ingress points they have been placed there. They do a great job of looking at the information there. They're typically signature based. So, and there are some small issues that come with signature-based technologies as well, but placed at the edge, they're quite effective. They're good for stopping cold in its tracks certain unwanted traffic or guarding against the use of ports that aren't supposed to be used. You also find these things, like I said, at major network intersections, places where it's very critical that you have at least some level of visibility. You would find an IPS there, or maybe even a firewall. And then, of course, in front of critical assets. Of those three scenarios, I would say putting an IPS in front of critical assets would be the most expensive, because in data centers, there's a lot of critical assets. And then there's a whole lot more happening in data centers these days. I think the archaic version of or the archaic vision of a data center is one in which there are a lot of physical servers all over the place, but that's becoming less and less the case, because people are beginning to, well, not beginning, it's well known now that VMware and similar technologies have huge cost savings. But then when you virtualize everything, then you also introduce yet another blind spot. And there's been various success with different types of security devices moved inside the virtual environment. Anytime you have a virtual machine that you're passing packets through, there's also a related decrease in performance. But fortunately, as we will discuss later, there's a way around that problem. Looking at communication between devices in the data center has also been problematic. If you're deploying things only at major network intersections, or if you're deploying an IDS off a span port on certain segments, then it can be quite difficult and technically complex to be able to see all communications going back and forth between all devices. So device-to-device communication, you may think, well, if we're preventing everything from getting in the first place, why do we care about what's going on between machines? Because as I'll highlight some of the reasons why we care in just a minute, but it's better to know than not know in those types of situations. And knowing what machines are doing between each other is really important because of my last point here, non-network access. So what I mean by that is if somebody walks into your data center with an infected USB stick or some sort of infected media, whether they deploy a laptop on the network for troubleshooting purposes, all it takes is for somebody to walk the problem into your network, and every single sort of security device you've got is immediately circumvented. So let's talk about just a couple of proof points here. There was a question that was recently asked by the ESG research brief, and basically the question is in your opinion, what are the biggest challenges your organization faces with regards to protecting the IT assets residing in its data centers? Well, so two of the biggest areas that are relevant to this discussion, where there was a good bit of response, as you can see here, is monitoring server activities and monitoring network activities. Now, both of those things sound trivial in nature. Oh, we're just going to monitor some servers, we're going to monitor the network, no big deal. But how do you really accomplish that with some of the traditional technologies out there like IPS and firewall and that type of thing? It does get expensive fast. That's not, you know, there's no marketing spin there. That's the truth. That can get very expensive very fast if you try to use IPS devices and similar technologies to cover all the major bases in the network. But fortunately, as we'll see later, there is actually a way to cover everything. But, you know, I think these two particular points here are very telling that there is now an increased awareness of the fact that monitoring what's actually going on as opposed to what's happening at the edge or major intersections is becoming much more of a priority. So let's dive into more detail on what the major threats are to the data center. Well, the malware is an interesting one. So a huge threat there is, like I said, if somebody walks something into the network, that's a nightmare scenario for not only data centers, but also for just networks in general. And if somebody did walk something into the network, it bypasses all the signature-based technologies if there's a signature for it in the first place. Then you've got a real problem. And how it starts spreading, fortunately, they do have telltale behaviors. Even if you don't have a signature for it, there are behaviors that for the most part, they all exhibit. We'll talk more about that in a minute. But anyway, so if somebody walks it in, then everything is, you know, all bets are off at that point. The other thing, too, is that even if somebody doesn't walk in something, let's say it comes in via the network, there's the zero-day problem as well. Depending on what IPS or IDS device or next-generation firewall you're using, there may or may not be a signature for this particular piece of malware. So it can come into the network just as easily. And then there's also the question of evading signature-based technologies in the first place. If you've got an IPS or a next-generation firewall, anything that's tasked with first normalizing traffic and then figuring out what to do with it, the process of normalization is a highly vulnerable process. RFC, I think it's RFC 791 basically says that anything that an IPS or a firewall can't make sense of, it has to pass. So if the attack is sufficiently camouflaged with a bunch of garbage in the TCP header, then it just goes right through. Or potentially it could. I'm not saying it will always, but it can happen. So malware is a huge threat, and once it gets in there and it starts spreading, of course, the rest is history. But then, of course, there's the denial of service. So data centers, depending on where they are, you know, if they're sort of internal to the company, that's a slightly different story. But more externally facing data centers generally have pretty high bandwidth available to them. And, you know, if you've got a lot of e-commerce servers and all this, that, and the other, of course it's going to be high bandwidth. But that's attractive to an attacker, especially one that's looking to launch a denial of service attack. You want high bandwidth. You want something that is going to allow you to blast out the maximum amount of traffic for the maximum amount of damage. And commercial servers are attractive targets. And the reason for that is that these servers themselves, these are typically not like 1U pizza boxes or those beautiful, slightly khaki-colored towers that we used to know and love from the 1990s. No, these things are really high-powered machines with multiple cores, and I mean, they're powerful computers, and so those become attractive launching pads for attacks as well. And then the big thing too is that if you have a denial of service attack that's originating from your data center, there's also potential liability there too. So, you know, data centers from a denial of service standpoint can be really attractive. You know, you could use, of course, there's the botnet avenue for doing a denial of service attack, but you know, if there's a convenient way to compromise e-commerce servers and then use the bandwidth available from a data center, then why not? As it happens, sometime last year, this became, at least briefly, and I'm not sure of any recent 2013 stats, but certainly last year, this was a rather popular mode of launching denial of service attacks. I'm not going to bother reading that name because I refuse to read a name that sounds so ridiculous, but you can see this really horrible word that's on the slide here, and to my point, terrible name, effective attack. Quite effective, and it's actually a little bit of a toolkit, and its primary purpose was to take advantage of content management systems that were vulnerable, like WordPress and what's the other, Joomla or something. The name escapes me, but in any case, it was designed to go after those, attack those, compromise them, and use their bandwidth in the data centers in which they were located to attack other targets. So without the knowledge of the operators of the data center, there were several content management systems that were compromised, and then they used the computing or the attackers used the computing resources of those servers combined with the bandwidth available at the data center to launch some really, really, really powerful denial of service attacks that were, and I apologize that I didn't cite my source here, there were something upwards of like 70 gigabits per second. So that's a pretty high bandwidth attack. They didn't have to farm a botnet. They didn't have to worry about potential, you know, the potential vector of infection for the bots. They didn't have to worry about that getting stopped. They just compromised these systems, and then they went for the gold on the attack. So, like here on my slide, it doesn't make use of any botnets whatsoever, and it was quite effective in what it did. Now, like I said, I wish I had for you some more recent stats for 2013, but there is, if you search for the name of this attack on Google, I would imagine there are only a handful of hits for such a ridiculous word, and you can read in great detail more about the write-up on this attack. It was quite interesting. All right, so enough doom and gloom. Let's talk about the visibility gap itself. You know, what actually causes the visibility gap, and then I'm going to give you the some practical ideas that you can think about to remedy this problem. So remember, first and foremost, that the perimeter is only part of the story. So much more is going on besides the perimeter. There's, like I said, there's the potential for non-network access to cause problems. There's the potential for the insider threat even within the data center, so somebody that works at the data center doing something malicious on one of those computers intentionally. So there's a number of other vectors of infection for a data center and an internal network other than the perimeter. And remember that perimeter-based security technologies are still far from perfect, and probably they never will be. You know, security is a constantly evolving thing, both on the defense and offense side, and so the best we can do is know our adversary, which is the whole point of this discussion today. And remember that signature-based technologies are absolutely critical. In no way would I ever attempt to disparage the hard work and effort that's gone into signature-based technologies, and of course they're one of the great cornerstones of security. So they're needed, and they must be at the perimeter. There must be firewalls. There must be segmentation, all the traditional stuff. But there's still the problem of what's going on from device to device and how to get that information without breaking the bank. So fortunately, all the other stuff you have on your network, and by stuff I mean things like routers, switches, firewalls, proxies, anything that can spit out a wonderful thing we call NetFlow. As long as it can spit out NetFlow, and as long as you have a device to collect and process the NetFlow, there is an incredible amount of information that can be gotten out of there. You can think of NetFlow as transactional, much like examining your phone bill. It shows what number was called, when it was called, and how long the call lasted. Those types of information can be gotten out of NetFlow. By itself, though, NetFlow is not terribly useful unless you do something useful with it. And what I mean by that is, you know, you think of like unsugared shredded wheat. It's useful in that it will sustain you, but it doesn't taste very good. And what we really do is we make it taste a lot better by doing things like behavioral analysis and adding additional security context to it. And I'll come more to that in just a second. So behavioral analysis is one of the key things that we provide with StealthWatch. So we take in NetFlow from switches and routers and anything that will basically spit it out, and we perform behavioral analytics on that information. And the reason that is valuable in bridging the network visibility gap is because NetFlow allows you to see every internal conversation that's occurring in the data center, in your internal network. So if there is infection that has been introduced out, you know, beyond the perimeter, or you know, some other means, NetFlow can spot some of the telltale signs of an active infection on your network. For example, if some random host or random server in the data center begins to scan other servers, we don't have a signature for it. In fact, we're not a signature-based technology at all, but we can see that this server has never scanned anything ever, and then all of a sudden it starts scanning. Or if you have a server that all of a sudden stops behaving like a server and starts acting like a client. These are all things that can be spotted using NetFlow that has some sort of behavioral analytics attached to it. And you know, because the valid points of today's conversation really have to do with NetFlow and behavioral analytics and the data center, there's all kinds of other information that StealthWatch can add to NetFlow to give it even more security context. Take, for example, the fact that we can take information from IPS devices in the form of syslog, and we can use that to increase the confidence of some of the things that we identify as being potentially malicious. So there's all kinds, and here comes the most corporate word in the entire universe that I love to use: synergy between some of these perimeter devices and solutions like StealthWatch to figure out if you actually do have a real honest infection on your network. So let's move on to slide number 8 here. So as I said, StealthWatch is a behavioral analysis solution that is designed and geared specifically towards security. So we do a rolling baseline of the behavior of the network, and we can spot anomalous activity. So for example, the malware thing. If a host a host which had been acting like a server starts acting like a client, these are the types of things that we can see, among other things. And as I was mentioning, it is possible to add other security contexts like usernames. StealthWatch can correlate user activity down to their name with specific things that have occurred on the network, which is really, really powerful because it gives you the ability to tie using NetFlow, which is only really layers 3 and 4, to specific user activity, and we can, in a future webinar, we'll get into much more detail on how that's actually accomplished. We can also do things like add application layer information to it through integrations with Cisco, and we have a upcoming integration with Palo Alto. Those types of things give us the ability to add more security context to NetFlow, which enables you to make better decisions about what's going on. Other things that we can do, and this is really, really cool as well, is take, for example, Cisco firewalls, ASA, ASR, and ISR, to be specific. We can take in-cell the network security event logging information from those devices, and we can actually tell you if flows were allowed or denied by the firewall, which gives you the ability to sort of audit your firewall. So if there is a flow that is established to somewhere and you know according to a security policy that it should be blocked yet it's allowed, that flow doesn't lie. So this will give you the ability to run back and make any potential correction in your firewall. Behavioral anomalies don't just occur in the form of, machine switching roles or spreading malware. Other behavioral anomalies would be, and this is most relevant for the denial of service type discussion, would be spikes in network traffic and being able to get specific alarms when traffic crests above a certain point. So when that happens, regardless of what's actually going on in the network, regardless of what your IPS or your firewall or any of that was saying, if traffic begins to get beyond a certain point at an egress, or beyond a certain level at an egress point, then you should be able to get an alarm, because that could very well be evidence that there's a denial of service attack ramping up in progress or whatever. Also, because NetFlow gives you that all-seeing eye sort of visibility into your network at a pretty low barrier of entry, we also have the capability of monitoring for any type of activity that occurs between your data center and a constantly refreshed list of botnet command and control servers. This is enabled, some of this intelligence comes from a technology partner that we use, and part of it comes from SLIC, which is the StealthWatch Labs Intelligence Center. Those two entities together provide us information on on the most active botnet command and control servers, and we can monitor to see if there's any activity established between your network and them, either inbound or outbound. And last but not least is the internal spread of malware. If a host becomes infected with malware, it doesn't, the method that the malware chooses to spread is, I won't say it's irrelevant, but it certainly doesn't mean as much, because what we're looking for are changes in behavior from a particular host. If we see any type of scanning activity from an internal host and it scans another host and then that host scans something else, using those different data points, we actually have a map that can show you how a piece of malware has spread throughout your network, which is invaluable for going back and cleaning it up. It's you can think of it as a boom for your oil spill. So let's talk a little bit more about bridging the gap and what this looks like. So just to put some meat on the conversation a little bit, in the upper left-hand corner, that is the DDoS. That is just one of our DDoS detection graphs, and so you can see very quickly things that you've got this giant spike in network traffic that's occurred over a sustained period of time. And then you can drill into that, and once you drill in, you can see the hosts or hosts that were responsible for that increased level of traffic. So very quickly, if you haven't spotted it via any other route, it makes it pretty easy to see where you need to focus your attention for your mitigation efforts. Similarly, for the malware infection, you can see the hosts that appear in this list are the hosts that have had the most number of offenses of what appears to be malware traffic. Now you can see that all these screenshots were taken from our demo system, which has a lot of data being fed into it. And even still, the number of hosts that you see here are fairly low, meaning that it's pretty high confidence that these hosts were infected with something, and you've got a list of approximately 6 hosts there that really look, or 5, that you can go investigate. And you can drill into this graph, you can right-click on this graph, you can go all the way down, and if available, you can get it all the way down to the name of the user that was associated with that machine at that particular time, which is incredibly useful. Now, in the lower left-hand corner, there's a lot of text on that screen, but the most salient point on that screenshot is something called the concern index. When you're dealing with any type of infection or any type of security technology, the biggest question that comes to mind is, are we dealing with a false positive here? Nobody likes to go chasing down false positives. It's a complete waste of time. So we have something called the concern index. And the concern index is it's basically a measure of how differently something has been behaving compared to how it's behaved in the recent past. So in this case, the top row that you see, that host is behaving approximately 17,000% different than how it's participated or how it's behaved in the past. When it reaches 17,000%, this is kind of like StealthWatch screaming at you, telling you that at 17,000%, that's really, really, really high confidence that there's something wrong with this host, that it is, it could be that the IP address was assigned to a different machine with a different role. However, it could be that that host, once you dig into it, has done something just crazy. And you can see on the side there, under the alerts, it says that it's been, there's pinging activity, there's a lot of rejects, and then there's, of course, most insidiously, a TCP scan. So this is just some random host in a random host group, and all of a sudden, it's scanning. And that's probably not a good thing, unless it's a Qualys server or something of that nature. A quick word on the host groups. We use host groups for everything, and basically what host groups allow you to do is, even though you may not have, for example, physical security controls between certain groups of hosts that behave differently and that should work differently, you can use StealthWatch to categorize those things into those host groups, and then we can monitor for activity between them and alert as necessary. So it's a way of getting logical security controls out for your network without having to implement a bunch of physical security controls, which can be more expensive and time consuming. With StealthWatch, you just create the host groups and set your policies. Last but not least, of course, is the botnet monitoring. That's the list I was referring to. That list is updated on an hourly basis, and we monitor for any activity that occurs to any of those known botnet command and control servers. So you would definitely get a shiny red alarm in the event that something on your network, no matter where it was, if it was a server in your data center, if it was a host on your internal network, you will get an alarm in the event that there's any established flow between you or any of those hosts, or even if there's an attempted flow, you would get some sort of a notification. So to specifically address the DDoS problem, I took this screenshot. This is a little map that we created for demonstration purposes, but the purpose of this slide is to essentially demonstrate the value of visual cues when you're dealing with something like the data center. This basically allows you to monitor, using NetFlow, the amount of traffic, even down to the service level, the traffic that's going to and from your data center. And you know that if you've got bandwidth X, and you never want bandwidth X to exceed a certain number, then you can create that, and then you can start monitoring the specific links that you've got to and from your data center to see if something gets out of control. You don't have to go dig through a bunch of NetFlow records. You don't have to go through a flow table. You don't have to do any of that. You can just have this console popped up, you can see very quickly, I mean here, that you can see that the service traffic for HTTP and HTTPS has begun to crest some sort of level that was set, and that's why it's now orange. So you're sort of in that warning area. If that turns red or something of that nature, then it's fairly high confidence that either there's been an abrupt spike in traffic, it could be the holidays, or it could be a denial of service attack. But the value here is that there are visual cues to represent all sorts of problems. And all you really had to do was enable NetFlow on all of your devices to get this information. So that is all of my talking for today, and I want to say thank you, and I guess it's now time to